With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, so today's question we have the potential associated with each electrode is known as electrode potential. If the concentration of each species taking part in the electrode reaction is unity, if any gas appears in the electrode reaction, it is confined to 1 atmospheric pressure and further the reaction is carried out at 298 Kelvin, then the potential of each electrode is said to be the standard electrode potential. By convention, the standard electrode potential of hydrogen electrode is 0.0 volt. The electrode potential value for each electrode process is a measure of relative tendency of the active species in the process to remain in the oxidized or reduced form. A negative E naught means that the redox couple is a stronger reducing agent than the H plus or H2 couple. A positive E means that the redox couple is a weaker reducing agent than the H plus H2 couple. The metal with greater positive value of standard reduction potential forms the oxide of greater thermal stability. Given the standard reduction potentials, E naught of K plus 2K is minus 2.93 volts. E naught of Ag plus 2Ag is plus 0.80 volts. E naught of Hg plus 2Hg is plus 0.79 volts. E naught of Mg plus 2Mg is minus 2.37 volts. And E naught of Cr plus 3 to Cr is minus 0.74 volts. The correct increasing order of reducing power is, over here this has to be Mg plus 2 to Mg. After that we have got order as K greater than Mg greater than Cr greater than Hg greater than Ag. Then Ag greater than Hg greater than Cr greater than Mg greater than K. Mg greater than K greater than Cr greater than Hg greater than Ag. Then we have got Cr greater than Hg greater than K greater than Mg greater than Ag. So now what we have got, we have to find the increasing order of reducing power. So what is reducing power? It easily reduces other substances. In simple terms, this is what it means to say. So now we have got, so if it reduces others easily, it will oxidize itself easily. So the substance which oxidizes itself easily will be a good reducing agent. So over here we have got E naught of K plus 2K is equal to minus 2.93 minus 2.93. So we can write it as E naught of K to K plus is equal to plus 2.93 volts. After that, E naught of Ag plus to Ag. E naught of Ag plus to Ag is equal to 0.80 volts. So E naught of Ag to Ag plus is equal to minus 0.80 volts. Then we have got E naught of Hg plus to Hg plus to Hg is equal to 0.79 volts E naught. So E naught of Hg to Hg plus is equal to minus 0.79 volts. After that we have got Mg2 plus to Mg minus 2.37 volts. E naught of Mg2 plus to Mg is equal to minus 2.37 volts. So E naught of Mg2 plus to Mg is equal to plus 2.37 volts. After this we have got Cr3 plus to Cr minus 0.74 minus 0.7474 volts. Cr plus 3 to Cr. So E naught of Cr to Cr plus 3 is equal to plus 0.74 volts. So when we write these in increasing order of oxidation, we get minus 0.80 is first, then we have second, after that we have this is third, this is fourth, and this is fifth. So which oxidizes itself easily? So oxidizing itself most easily will be number 5, and the one which will oxidize itself with maximum or with very high or very low with very high efforts is Hg is Ag, this one. So for order we have got Ag, then we get Hg, after Hg third number is Cr, and after Cr fourth is Mg, and after Mg we have got potassium. So the order is Ag, Hg, Cr, Mg and K. So the answer is option number 2. Option 1 is wrong, 3 is wrong, 4 is wrong. So the correct answer is B. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubt and App today.